Welcome back, everyone. Here we are for topic number 2, where we're going to discuss different styles you can use to present your results. So to give you an example, what I did is I found one of my shortest articles, a research note, and asked you to read it to kind of put in context the experiment. So I'm not going to cover again the experiment, but I will talk about the results because that's the most important section for us today. Let's just go back for 1 second. Sorry, a few more thoughts here. So what I'm going to do is I'm going to show you 4 different styles of writing result sections. And I don't think this is an exhaustive list of ways to write your results, but these are kind of the common ones that I see. Now, all of them are appropriate. Some of them, there's trade-offs to the different methods, but often it just comes down to the style that the author likes to use. Some techniques or some styles are more common in some fields than others. Also, the journal that you're writing for sometimes dictates which style that you'll use. So it does come a lot down to choice and maybe even your academic training. Who taught you how to write result sections? Which ones do you like when you read? Which do you try to emulate? So we'll look at all 4, and on the capstone assignment, you're welcome to use any style that you prefer. So here are the data from that research note. So in it, we presented a very simplified version of the data. It's a research note, so it has to be short, and we're really focusing on reaction time. So we have 4 different conditions. We have a control condition, and we tested people making symmetric movements and people making asymmetric movements. So we won't it doesn't matter what those movements were, just they're 2 different types of movements. And what we were most curious is how much longer were asymmetric movements compared to symmetric movements. And you can think of this as a reaction time cost to make an asymmetric movement. Then we had 3 other conditions where we made the task a little harder. So we expected to see longer reaction times, and we did. And that's not the interesting part. The interesting part is, well, or what we are interested in is what happens to the reaction time cost in these various conditions. Oh, here, let me move a few things out of the way here. Sometimes it does not. There we go. Okay. Move that. Move me. There we go. Okay. So in the article, we actually don't present the ANOVA. We skip right to the a priori comparisons, and that is completely legitimate, and it's actually also how the reviewers wanted us to present the results. With just a priori comparisons, there's not a lot of style choices to make, so what we'll look at here in this presentation are first the ANOVA, then the a priori comparisons written in different styles. So if you look at these data, these can be analyzed with a 2 symmetry. So is it symmetric or asymmetric? So blue or orange here. And then our 4 conditions. Control, when the stimuli were dim, when the response was incompatible, or when you had to make a reversal movement. So that's our main ANOVA. Now because our primary interest is what are the size of these asymmetric costs, so in the control group, this is how much long asymmetric movements are from symmetric ones. And we can measure that in all 4 conditions. And this here, I'm going to isolate the size of these on the next graph. So notice how this one is about this big, these ones look a bit bigger, and this one looks about the same size. So here we're just going to look at the difference in reaction time, or reaction time cost is isolated on the next slide. So here it is. We're now looking at those reaction time costs. This is in control. So this blue bar is the same size as this orange bar over here. And then we have the size of those bars, the difference, the reaction time cost, for dim, incompatible, and reversal movements. And this is where we had 3 a priori comparisons. So we weren't interested in, are these different in the experimental group? We wanted to know, is the control group different from the dim group? Is the control group different from the incompatible? And is the control group different from reversal? So that's 3 a priori comparisons. And they're one direction because we just wanted to know, are the experimental groups larger than control? It doesn't really make any sense for them to be smaller than control, so we're testing one-directional, one-sided t-test. Okay, let's get into the different ways to report these results. And this first one I call just statistics, no interpretation. And this would be kind of the traditional method of reporting results sections. You still sometimes see results reported this way. But if you read an old paper, say from maybe before you were born, the results sections tend to be very stats oriented. So that's what we'll see here. So I start with reaction time was analyzed with a 2 symmetry by 4 condition repeated measures ANOVA. So I'm reminding them of the statistic. The output is shown in table 1. So one thing you'll see with very descriptive statistics is they often show you all of the stats, which are often done in tables. So here in the table, boom, you can see all of the results of that 2x4 ANOVA. So we have our symmetry, condition by symmetry, our interaction. We have the error terms. We have the sum of squares, the degrees of freedom, the mean squares, the F values, the P values, the epsilons when there was departures from sphericity, and our effect size and partial eta squared. So it's a lot. And it's basically the output from SPSS put into a table in a manuscript in APA format. So it's a lot to look at, and here you can see that we have a significant main effect of symmetry, a significant main effect of condition, and the interaction is not significant. So let's go back to the writing. Let's pick up where we left off. So reaction time for asymmetric movements was significantly longer than symmetric movements. And here I've even given those values on their 95% confidence intervals. The significant main effect of condition was analyzed with post hoc pairwise comparisons, which suggested that all conditions were significantly different from each other. So these two sections here were basically reporting the two main effects. So this is the result of the main effect of symmetry. So they're significantly different from each other. We saw that in the table. Then we report the significant main effect of condition. And the results of that in this case were kind of easy because all groups were significantly different from each other. And last up, we've got our 3 a priori comparisons. Now there's a bit of reading here, so I do want to let you know that I've written these results section into a Word document, and that's up on Blackboard. So if you want to refer to that document instead, it's a little easier to read than, say, the slides. So 3 a priori comparisons tested whether the asymmetric costs in the experimental conditions were larger than the control condition. And here I give the size of the cost in the control condition. The reaction time cost in the incompatible condition, so about 35 milliseconds, was significantly larger than the cost in the control condition. Okay? The reaction time cost in the dim condition, about 33 milliseconds, was not significantly larger than the control condition. The p-value, which was 0.053, you can also see it here, however, was close to the significant level of 0.05. The reaction time cost in the reversal condition, so only about 24 milliseconds, was not... Oh, and here I wonder if I have a typo, or are these both coincidentally both 24.1? I think they are, because the confidence intervals are different. Sorry, let's start that over. The reaction time cost in the reversal condition, 24.1 milliseconds, was not significantly larger than the control condition. So it's pretty dense. We've got 3 a priori comparisons. We've got the values of these as well. So it's fairly dense reading. A lot of numbers and statistics. So let's think about the positives and negatives of our first technique. So the positive is that it's actually the easiest to write. It's the most recipe-like, I like to think about. You don't have to worry too much about the style. You just write a list of your statistics with a little bit of writing in there. But it's just a lot of this statistic, this statistic, this statistic, this statistic. So that's fairly easy to write. The negative though, so easy to write, the trade-off of course is it's hardest to read because we prefer reading sentences. We don't like reading numbers and statistics kind of over and over. A good thing, and this comes back to our researcher degrees of freedom, is that all the statistics are there. Nothing is hidden. So if you're curious, say you write just that, in a different style you might just say the interaction was not significant. Well, the reader might be curious if you don't present any more detail than that. So yes, the p is going to be greater than 0.05, but was it close? What was the effect size? What are the details? And here, all of those details are given. That table literally has everything in it. When I read results section like this, one of my criticisms is that I feel like the author is saying, here's my SPSS output, you interpret it. And I prefer, different people have different opinions on this, that the author presents some of their own interpretation. Create more of a narrative, a story to the results section. The downside of that, though, we'll see later, is that does involve researcher degrees of freedom. They start to begin to choose what and how they present things, and we do need to be careful about that. Another positive is that this is one of the most concise or shortest ways to write your results, and often we're constrained by how long our manuscripts can be, so if the results can be short, we can put more emphasis on maybe more important discussion topics. But by being short, it's also very dense. So when we read through that, it was a lot of confidence intervals, means, statistics, very dense reading. And finally, when you're just reporting stat, it's hard to emphasize your most important results. And the reader might be wondering, well, what's most important here? Is it the main effect of condition? Is it the main effect of symmetry? Is it the interaction that was non-significant? Or is it the a priori comparisons? Everything kind of ends up having equal weight. So again, there's not much narrative where you can really emphasize your most important results. Let's look at our second method. Now this one I call statistics and interpretations, where we are going to provide a bit of a narrative, giving interpretations as we go through our statistics. And this is really a common method, maybe the most common, and it's also the one that we've been seeing throughout the class so far. So it starts similar. We're going to remind the reader of the statistic we're running. Reaction time was analyzed with a 2 symmetry by 4 condition repeated measures ANOVA. And then this is, I'm sure you're used to this now and how we've been writing. We now mention our significant effects. There are significant main effects of symmetry and condition, and we give those stats. So they're not in a table. The table can be nice because it's fairly organized. It does take up a lot of space, so here we're kind of cramming them into the sentence. But to improve the narrative a bit, we kind of separate the writing from the statistics. So if a reader is interested in the stats, they can look at them. But if they're not, they just want to read the narrative, you can just read the first part of the sentence and then skip the stats if you trust the researcher. Oh, we have a guest appearance from Elias. Would you like to say hi?
Yes. Hello.
Thank you. Are you gonna go now? Oh, lunch.
We can hear what they're saying.
Oh, it's just we're recording a video.
Oh.
Yeah, they'll watch it later.
Oh.
Yeah.
Hi.
All right.
We were recording a video and
We'll see if he comes back again later. All right, so let's look at the next part here. So nothing that different. We're just separating the writing from the statistics, providing a little bit of a narrative. We'll see more narrative next. So we need to interpret our main effect of symmetry, and this is very similar to what we did before. The main effect of symmetry suggested that asymmetric movements had longer reaction time compared to symmetric movements, with just a little bit added on the end here. So then I say, which is what was predicted. So I'm reminding the reader about what we went over in the introduction, where we said, yeah, symmetric movements should be shorter than asymmetric movements. It's not a big deal. That's what we expect in every condition. And we're just saying, yeah, things that we expected to happen are happening. If this was an unexpected finding, if this was a very important finding, then you could provide more narrative here to emphasize that point. Now we're going to look at the main effective condition. So I remind the reader pairwise comparisons, so they say, okay, we're doing pairwise comparisons, on the main effective condition suggested that all the conditions were significantly different from each other. And then I actually provide a little more information here. So I don't know if this is necessary or not, but it's maybe a little more narrative. Reaction time from shortest to longest was control, reversal, dim, and incompatible. So there's a lot of data presented there. Not the easiest sentence to read. And then I do get to our interaction. So the condition by symmetry interaction was not significant. And then if the reader is so inclined, the stats are there too if they want to take a look at any of the details. So what was the exact p-value? Was there a violation to sphericity? Well, yes, there is, and we've used the Winn-Felt correction. Now we're going to get to the costs with our 3 a priori comparisons. And the first thing I do here is I remind the reader what I mean by a reaction time cost. And I think this is helpful. So your reviewers, your readers are not necessarily going to be people who are as intimately familiar with the measurements as you are. So although I might think, oh yeah, it's a reaction time cost, I went over that in the introduction, I think it's always good to remind the reader what you mean by that and what is the calculation. So here I start with the bimanual asymmetric cost in each condition was calculated by subtracting the reaction time for bimanual symmetric movements from bimanual asymmetric ones. So boom, we've helped them remember that this cost is the difference between symmetric and asymmetric movements. And additionally, I've provided a figure. So these bimanual asymmetric costs are shown in figure 1. One of the reasons I've done this is the most important result in this paper. And if it's your most important result, you should have it in a figure. Some advice to especially undergrads when they're reading research is maybe just look at the figures, because if it's important, it should have a figure. So here's that figure. So we've seen this before when I was talking about it before we went into our sections. And the other thing I've added to it to help someone identify the statistics very quickly is that I've added the significant differences. So the control group and the incompatible group, as soon as you look at this, you're going to say, yep, they're significantly different. Now later on, you're going to see where I have a figure for the entire 2x4 ANOVA. And there, the stats are too complicated to put on the significant differences. So sometimes it's possible to add, these bars with stars like this. Other times, your figure might be too complex. Here, it's quite straightforward with 4 groups and 3 a priori comparisons. So I added this on. Okay, this is quite long here, this section. So if you don't want to read it off the slide, you can look at the Word document. I will go through it now. Just because in the subsequent sections, this part doesn't change that much because a priori comparisons are fairly straightforward, so there's not really too much style you can add to them. So 3 a priori comparisons tested whether the asymmetric costs in the experimental conditions were larger than the control condition. The reaction time cost in the incompatible condition was significantly larger than the cost in the control condition. And this is the one that we saw in the graph. This suggests that response selection contributed to the bimanual asymmetric cost. So this part here, this is where we've added interpretation into our results. A little bit of narrative telling or reminding the reviewer what it means. That significant difference is important because it means something about response selection. The reaction time cost in the dim condition was not significantly larger than the control condition. The p-value, however, was close to the significant level. This suggested that stimulus identification might contribute to the bimanual asymmetric cost. So this last sentence for the dim cost is again some added interpretation. The reaction time cost in the reversal condition was not significantly larger than the control condition. Now we're going to add on the interpretation. This suggests that response programming did not contribute to the bimanual asymmetric cost in the control condition, and important note here, which was contrary to our prediction. So we didn't predict this. This is odd, so we want to highlight that. even if it's just with half a sentence here at the end. So the way this differs from our previous way of writing is that we're adding in interpretations. And I think this helps link your introduction to your results. So things like, hey, this was contrary to our prediction. Oh, by the way, when this is significant, it tells us something about response selection. And it also, not only is it pulling the narrative from the introduction into the results, but you're then going to return to that in the discussion. So you're almost priming your reader for what you're going to return to in the discussion. Now you might be wondering, how much interpretation is appropriate to add into the method section? And that has different opinions. So in the first writing style, where we have statistics and no interpretation, someone who writes that way might say, or their opinion would be that you don't put any interpretation. They might read this and say, that interpretation belongs in the discussion. It shouldn't be in the results. But I think more and more the trend is to add more interpretation into the results, to create a narrative, to have a story that connects the intro to the method to your discussion. How much interpretation do I like to do? Well, what I like to do is I like to interpret each result on its own. So let's say we had two dependent variables. Let's say we were analyzing reaction time and movement time. So here we've looked at reaction time and I've interpreted reaction time. If we had movement time results, I would present the movement time results and I would interpret the movement time results. What I wouldn't do in my results section is interpret reaction time and movement time, kind of how they coexist together. Maybe there's this trade-off between speed and accuracy. That sort of complex interpretation of more than one dependent variable, that I put into the discussion, because that's kind of going beyond the statistics and getting more into comparing two different dependent variables together. So I would leave that for later. Now, if your statistic instead was a correlation between reaction time and movement time, then it would make sense to interpret that in your results because those variables are being combined. The other thing I don't like to do in my results section, this is quite rarely done, is make interpretations that extrapolate beyond your statistics. So those sort of extrapolations or conjectures or theoretical musings or applications to clinical practice, those should be in your discussion. Those are beyond your statistics, so they do not belong in the results section. Also, if you want to make ties to previous literature, even if it's your own literature, I think that should also be in your discussion section. So now, in your results section is now not the time to say, hey, we found this, well, this group found this, we previously found this. No, that belongs in the discussion, at least in my opinion. So what are our positives and negatives here? Well, this requires a bit more skill to write, so it's going to take a bit more time. And I think that's both a positive and a negative, because the moderate difficulty to write, maybe for positive I should have said well, it's a moderate difficulty to write, but I'd say it's more readable. Is that our next point? No, our next point is that it's medium length. So the length is a little bit longer, which is good and bad. It's longer, but it's longer because we're providing a narrative that makes it more readable. Yes, so there, and that our last point is provided, that we're providing some narrative between statistics. So we're helping the reader understand the statistics, we're emphasizing what we think is important, and we're generally making it more readable by connecting our intro to our results, which we're going to then really make more theoretical interpretations to in our discussion. All right, we're going to continue with this trend of adding more narrative. So we started with kind of no narrative, then we had a bit of narrative, and the next two examples we're really going to emphasize the narrative. So this one I like to call visible patterns, statistics, and interpretations. So the first step is we're going to show the reader our data, usually with figures, but it could be a table or even just the means and confidence intervals. We're going to say, hey, this is the visible pattern, and here are the stats that support it. And it can be a nice way to walk the reader through your figures so that they're relying more on the pictures and the narrative. Okay, so we start the same way as before. We say, hey, we're doing an ANOVA. Then we add in mean reaction time is shown in figure 2. And we want them to look at figure 2 because we're going to start talking about the visible patterns. Before we look at figure 2, let's just read this next sentence. Note that bimanual asymmetric movements collapsed across conditions had visibly longer reaction time than symmetric movements. So we're saying visibly, we're not saying statistically, we're just saying when you look at them, notice that bimanual asymmetric movements are longer than symmetric ones. So we're priming the reader, when you look at the figure, take a look for that. So here we go. So here's figure 2, and yeah, if we look at the pattern, we're basically saying these orange bars, across all conditions are longer than the blue bars. Okay, as a reader, you're like, yeah, I see that. Now we present them with the statistics to that. This predicted bimanual asymmetric cost was supported by the significant main effect of symmetry. So two things here. We're saying, one, yeah, we predicted this. This happened. We predicted it. Not a big deal. Or our experiment is working. And it's supported, so this visible pattern is supported by the significant main effect of symmetry. So we say, hey, take a look at this. Here's our interpretation and the statistical result. Next up, we say reaction time is visibly longer in the experimental conditions, so dim, incompatible, reversal, than the control condition. So if we go back to our figure, we're saying that these reaction times are all longer than in control. So we're telling the reader to note that. So this fits with our assumption that the experimental conditions had greater demands on information processing than the control condition. So again, we're saying, this is what we expected. It came true. These results were supported. So now the stats. They were supported by the significant main effect of condition and the post hoc pairwise comparisons. So reaction time was significantly longer in the experimental conditions compared to the control conditions. The experimental conditions were all significantly different from each other, and then we add in a little interpretation here, but this does not matter when using the additive factors method. And that's theoretically beyond what we need to worry about here, but we're just telling the reviewer, don't get bogged down that one experimental condition is different than the other. That's not important for what we're looking at. So now we're going to get to the a priori comparisons. And again, just like before, we remind the reviewer what we mean by these asymmetric costs. And we say, hey, check them out in figure 1. So here's figure 1. The reviewer sees, the reader or reviewer sees them. And already, very quickly is going to know, oh, these two are significantly different. The other ones are not. And then we present that. And this is very, very similar to what we saw in our last section. Mostly because it's hard to be very stylistically inventive or different when we're just talking about 3 a priori comparisons, which are 3 t-tests. So I'm not sure if there's actually anything different here. So what are the positives and negatives of this technique? So the positive is that the narrative has more emphasis than the statistics. And of course, we prefer reading sentences than we do, numbers and statistics. And not just the narrative has more emphasis, but we're also giving the figures more emphasis by cueing the readers to look at them and also telling them what to look for. I'm sure you've had the experience where it says, oh, check out figure 1, and you look at it and it's just a monstrosity of information. You're like, well, this is obviously important, but what should I focus on? So this technique is good because we're helping readers look at what we think is most important. A negative, I would say that it has not moderate plus difficulty to write. It's more involved than just the statistics and interpretation, so that increases our difficulty. That also increases the length of the section. And it can seem a bit redundant because the writer is giving you the pattern, telling you to look at the figure, then giving you the statistics, and then giving you the interpretation. So it adds up. And if you look at this in the Word document, I think this is definitely the longest section. What you can do is you can choose when you're going to add in this visible pattern. So maybe you only cue them to a figure and talk about it in this manner when it's important or when it's really complex and you feel a need to walk your reader through it. So you don't have to decide, I'm going to use this technique for all of my results, but you might just want to use it when your results include a figure or for your most important or complex results. Okay. Sorry, I confused myself by the title here. All right, this is our last example. And this one is, I would argue, the hardest to write, especially to do it well. So you're going to talk about the patterns. You're going to support that with statistics, but you're going to kind of hide the statistics. They're going to be as hidden or least emphasized as possible because we don't like reading statistics. And then you'll also give interpretations to help with this narrative. So the reaction time results are shown in figure 2. So we're already saying, check out figure 2. We've seen it before. Note that bimanual asymmetric movements collapsed across condition have longer reaction time than symmetric movements. So this is essentially the main effect of symmetry, but we don't talk about it in that way. We don't say, hey, there's a main effect of symmetry, this is what it means. We jump right into the interpretation, and then we kind of hide the stats afterwards that supports that. This is evidence of the predicted bimanual asymmetric cost in every condition. So there's, again, our interpretation of that result. Reaction time was longer in the experimental conditions than the control conditions. So what are we referring to there? That's the main effect of condition, and we're even saying the results of the post hoc comparisons. So we support that with the main effect of condition and with our post hoc p-values. But we're really emphasizing the results and just kind of almost as an afterthought mentioning the statistic or just putting it there. I won't say sweeping it under the rug, but really de-emphasizing it. This fits with our assumption that the experimental conditions had greater demands of information processing than the control conditions. So again, we're interpreting the main effective condition. Let me move me here. The experimental conditions were all significantly different from each other, but this does not matter when using the additive factors method. So here, this is the result, or this text describes the result of the ANOVA, but we've gotten entirely away from saying, hey, there are these main effects, there's this interaction. Those stats are still here, at least the main effects are, the interaction. That one has been swept under the rug. But the stats are really downplayed. And I think if you were to ask anyone which one is easiest to read, you would probably say this one. Although if you said, which one is it easiest to find the statistics that supports the results, you would say the first method, and this method you would say is the hardest. It's like, okay, if you are interested in these numbers, you'd have to think, okay, well, what is this? And it would take a while to realize, oh, that's the main effective condition. And then after a while you might realize, oh, they never actually report the interaction. These are the a priori comparisons here, but this is very similar to what we've already seen before. And it's really because in those sections, the stats were already just kind of added on the end. So these two groups are different, here's the t-value. These two groups are not different, here's the t-value. So here we really couldn't improve on the narrative by hiding the stats any more than we already did. So what are our positives and negatives? So a positive is all the emphasis is on the narrative. It's probably the easiest to read. It's going to provide the best story, the best connections from your intro to your results, to your discussion. That makes it the easiest to read. The length is medium. It's not as long as our last example because you're always having to kind of give the visible pattern, the statistical results, the interpretation. You kind of had to do everything multiple times. Here you actually save length by not going into visible patterns and hiding your statistics. This obviously brings up the topic of researcher degrees of freedom. So here the researcher is choosing what to write, when to give statistics, when not to give statistics, and that could be abused and cause a problem with your research or degrees of freedom. So that's something you need to consider when writing or reading this sort of section. Negatives. So I would say it's the most difficult to write well. I have not used this technique yet in a manuscript, maybe elements of it here or there, but it's hard to do. And I even struggled a bit doing it here with just this kind of one ANOVA. So it's difficult and difficult to do well. Back to research degrees of freedom. If you're picking which statistics to report, then some are hidden, only some are reported, and this could definitely be abused. Now, when might you use this style? Well, I think it's a great thing to try. I think it's really great to read. When you don't necessarily have to use it, but there are some journals that do require a style like this. And these are often very, very high impact journals where the articles also have to be really short. So I don't know if you've ever seen any of these yourself, but something like Science or Nature are very high impact, and often the articles are very short. And typically in those articles, the results section is very, very small, and it's actually at the end of the paper. And that's where some of the technical information is kind of hidden. There's no. It goes right from introduction and method into your discussion, and what you end up getting in the discussion is this kind of blended section where it's the results and the discussion, which kind of looks like this technique here, where you talk about the patterns and you kind of hide the statistics. So let's summarize these 4 techniques. So I think you can think about them in the order we discussed them as kind of a continuum. So when we talk about just statistics, no interpretation, there's really no narrative. It's heavy, all stats. And when we look at our last technique where we're going to these patterns and hiding statistics, this is almost all narrative or mostly narrative. And the middle two fall somewhere between them. The other thing is, I would say that just statistics is the easiest to write because you're just kind of reporting your F and T values as they come out of SPSS. So that's probably the easiest to do. Whereas when you're hiding the statistics and going to the patterns, that's really hard to write, at least in my opinion. Now, when it's the easiest to write, I find that's probably going to be the hardest to read, especially for someone who's doesn't love statistics, or maybe you use a statistic that they're unfamiliar with, and if you're just giving me all the stats and I don't understand, say, a MANOVA or an ANCOVA, then I'm going to be lost. But if you've done an MANOVA and ANCOVA, say some sort of stat that the reader is unfamiliar with, if I provide narrative with that and hide the statistics, then that's going to be much easier for me to read. And finally, we have to connect this back to our researcher degrees of freedom. And just statistics, there's no researcher degrees of freedom there. You're just saying, bam, here are all my statistics. So nothing is hidden, and an intrepid reader can pick that apart and find anything they want to. But when you start hiding your statistics, the author is deciding what to present and how, what not to present. So there's many researcher degrees of freedom to this. And it could be tempting, to hide things or exclude things, to start to bias your alpha. So when they read it, they think it's 0.05, but in fact you've made all these decisions that has inflated your alpha. So that's a quick overview of 4 different ways to write your results section. None of these is the correct way unless a journal says you have to write it in a certain manner. And these styles are not necessarily used exclusively. When I commented on this at least once before, so some of your results you might show in a very traditional way. You might say, hey, here's a table with some ANOVA results. And maybe that's because that ANOVA was maybe not that interesting. Other results that are key to your experiment, you might start to add in a lot of interpretation. You might walk the reader through the visible patterns if it's very complex. And you don't necessarily do that in all of your sections. So think about that too in your writings, that there are different styles, and you might also transition or upplay one more than another depending on what you're trying to convey and when. So I'll see you soon in our last section detailing the capstone assignment.